Hello everyone, my name is Tet Sean, and today my group and I from Swinburne University Technology Sarawak are going to present a topic on hydrogen fuel cell cannot replace fossil fuel internal combustion engine for road transportation. Before we begin, here's the review of our presentation. We'll first start off with the introduction, and after that, me and my group members will take turns discussing the arguments. We'll then end it with the conclusion and references. What is fossil fuel combustion engine? According to Oxford Dictionary, fossil fuel is a natural fuel such as coal or gas that is formed by the remains of organisms on land millions of years ago. Have you ever wondered why we use fossil fuel to power our cars? Well, according to JESA 2010, it is because fossil fuels are cheap and yet very efficient. However, using it releases greenhouse gases which contributes to global warming. How is hydrogen fuel cell used for transportation? Well, refer to this diagram, and as you can see over here, two hydrogen from the storage tank will collide and be split into positive hydrogen particles and electrons. The chemical equation involved is 2H2 produces 4 positive hydrogen ions and 4 electrons. The two catalysts over here, mainly made from platinum, lowers the activation energy. Therefore, on the left, it breaks the hydrogen molecules and ionizes it. The proton exchange membrane only allows positive hydrogen ions to pass through. As for the electrons, it produces an electric current and thus running the car, which is the light bulb. Oxygen from air then collides with the positive hydrogen ions and produces H2O, and it then exits through the exhaust. The chemical equation involved over here is O2 plus 4 hydrogen positive ions plus 4 electrons equals to 2H2O. So, for my first argument, it's the problem with storage. According to NanoPack, hydrogen has a lower volumetric energy density as compared to fuels such as gasoline. This means that a larger amount of hydrogen is needed to produce the same amount of energy as a regular vehicle. Therefore, a large tank, sometimes as big as a car's trunk, is needed to store the huge amount of hydrogen. Next, according to engine technology, hydrogen is stored in extremely high pressure. On some cases, the valve will get plugged up and causing the pressure to continue rising. This means the hydrogen has only one way to exit, which is by force, also meaning exploding. This is dangerous for the passengers and the driver inside the car.
Thank you, Sean. Hi, I'm Cindy. Now I'll be moving on to the next argument on why hydrogen fuel cell cannot replace fossil fuel combustion engine. It is because of the cost problem of the hydrogen fuel cell. According to Nice and Strickland 2013, the hydrogen fuel cell consists of expensive components such as the proton exchange membrane fuel cell, also known as the PEMFC systems, gas diffusion layers, and bipolar plates. All these expensive materials made up of 70% of the system's cost. Besides that, hydrogen fuel cell also consists of precious metal catalysts like platinum. And according to engine technology article, platinum is very costly and its price will increase in the future. Next, Combustion 2013 states that the Toyota's first hydrogen fuel cell engineered car will reach the price of 5 million yen, which is 1 million USD. Therefore, this shows that hydrogen fuel cell is very costly and not everyone can afford to be a green revolutionary. Furthermore, the statistics shown by the engine technology article, it states that hydrogen fuel cell is currently too expensive to be afforded and they are only available for a few demonstration fleets. Now I shall pass my time to Erich.
Thanks, Cindy. For my part, third argument is hydrogen fuel cell is not power efficient due to the evaporation of the hydrogen. According to an article titled Hydrogen, hydrogen contains much less energy than gasoline or diesel on a per volume basis. This makes a fuel cell vehicle cannot go as far as a comparable gasoline vehicle, even though it has been demonstrated that the range traveled by a fuel cell vehicle are comparable to conventional vehicles, which is only about 400 miles different in the range. But does hydrogen fuel cell engine has the capacity to run a larger vehicle or replace the engine of an aeroplane? Abhishek Agarwal states that the hydrogen evaporates. The insulation is not a perfect process, and the hydrogen evaporates out of the cell at roughly 1.7% a day. This means eventually cars are going to need a fuel up. Now you might face another problem. Where can you get the hydrogen to fill up for a vehicle? In a recent study, fuel cell vehicle Bosell explained that a hydrogen economy is a wasteful economy. Large amount of energy required to isolate hydrogen from natural compounds. The gases still have to be packaged by compression or liquefaction in order to transfer the energy carrier to the user, plus the energy lost when it is converted to useful electricity when fuel cells with fuel cells. This leaves around 25% only for practical use, which is an unacceptable value to run economy in a sustainable future. According to Karin Nice and Jonathan Strickland, if the fuel cell is powered with pure hydrogen, it has the potential to convert 80% of energy content of hydrogen gas into electrical energy. However, we still need to convert the electrical energy into mechanical work, which is accomplished by electric motor and inverter. The average efficiency of electric motor and inverter are around 80%. This gives an overall efficiency of 64% only when hydrogen is used in an engine. However, if the fuel source is not pure hydrogen, then the vehicle will need a reformer. A reformer function is to convert hydrocarbon or alcohol fuels into hydrogen, but the problem is they generate heat and produce other gases beside hydrogen, so the hydrogen that comes out of them is not pure. As a result, this lowers the efficiency of fuel cell. Fuel cell steering committee also found out that the process of reforming hydrocarbons via reformer to produce hydrogen is technically challenging and not environmental friendly. This diagram shows the comparison in distance can travel by vehicles with different kind of engines. Based on this research, when same quantity of energy was applied to each vehicles, the results showed that hydrogen car Honda's FCX can only travel 13 km, which has shortest range among all the cars, while combustion engine car is able to travel 3 km more than that. This proves that combustion engine has a higher power efficiency compared to hydrogen car.
Thank you, Erich. I'm Megan, and now I'm going to move on to our next argument, which is the obstacle faced while dealing with the delivery of the hydrogen fuel. The two main obstacles faced are the safety measurements and its feasibility. In order to deliver hydrogen gas in the form of gaseous state to liquid state, air compressor is needed to be installed in vehicles. However, as stated by Nice and Strickland, the current air compressor technology that is available at the moment is not suitable to be installed in vehicles. Hence, it makes the delivery of hydrogen fuel cells to be more difficult. Furthermore, even if the technology to compress air is available for vehicles, constructing a specialized hydrogen fuel station will take a lot of work too. An article titled "What are the safety concerns of fuel cell 2013" suggests that specialized hydrogen fuel stations will be needing pipelines, fueling stations, hydrogen generation plants, etc. Imagine all the new fuel stations that has to be built if the revolution of hydrogen fuel does happen. That will take up a lot of energy, money, and risk. In addition, Agarwal also agrees that a customized hydrogen filling station is hard to find, leading to difficulties in hydrogen fuel delivery, and that it is troublesome if a specialized hydrogen filling station is specially built. Not to mention that the delivery of hydrogen fuel is extremely dangerous. As you can see here in the map, the yellow dots are the number of hydrogen fuel stations planned, and the green spots are the only hydrogen fuel stations that are in operations, which is only 212 of them worldwide. As stated by Agarwal, there will be risk for the fuel cell to explode, which is caused by the high pressure in the valve during the delivery of hydrogen fuel. When the pressure is too high, the valve will get plugged up, resulting in an explosion of the fuel cell. It was reported by Wing that on the 4th of May 2012 in AC Transit's Linde hydrogen fueling station in Emeryville, California, a small explosion has occurred due to the leakage of hydrogen fuel from the valve that cannot be detected. In conclusion, we strongly agree that hydrogen fuel cell cannot replace fossil fuel internal combustion engine for road transportation because it faces problem with the storage, cost, and power efficiency. Also, the delivery system for hydrogen fuel cell is very troublesome. Thank you everyone for your time. And these are the references used to support our arguments. Thank you.